But in here, we did this. And I just want to refresh your memory on this. This is really easy. It takes 4 weeks for the moon to go all the way around. So you can divide this thing up into quarters, and each one's a week. So from A to C is about a week, and C to E is about a week, and E to G is about a week, and G to A is about a week. But A to B is a half a week. A to F would be how many weeks? 2.5, because you got one here, another one there, and then a half. A to H would be how many weeks? Yeah, resist the temptation to go this way. Why can't you go that way? The moon doesn't go that way. Yeah, the moon goes counterclockwise if we're looking on the Earth's north pole. So this would be 3.5 weeks. And all the way around is about 4. It's approximately. So this doesn't ask you about, doesn't say how many weeks is it until this time or that time. This one asks you about eclipses, like when's the next eclipse? So let me do this on the board. And I'm going to turn the projector off, I think, because that's just going to confuse the heck out of you. But whoever's watching this, they can see what I'm doing. I'm just doing that to see where I am over there. So where do you want the sun to be? Somebody tell me. Top, bottom, left, right? You said right before anybody else. So I'm going to put the sun over here. This is just kind of a weird way to do it, but it's okay. Sun's there. And this is the edge of the sun. And the sun's rays, I'm not going to draw the sun's rays, but I'm going to put the Earth here. And then I'm going to stick the moon in. The eclipse that we have on April 8th is what kind of eclipse? Is it a solar or a lunar? Solar. So the first one I want to do, I'm going to do a solar eclipse. And in a solar eclipse, what's it going to be like on the Earth when we're experiencing it? Dark. Why is it going to be dark? Because the moon's shadow is going to be on us. And it's going to be the umbra. That's the darkest part of the shadow. So if I want to put the, first I'll say this is the North Pole. And I might as well go ahead and darken the Earth just for reference. This is the dark side of the Earth because the sun's over there. And the Earth is spinning like this. And we can do time of day. So we're going to be over here in the day. It's going to be 2 or 3 p.m. I don't remember exactly. Where do I need to put the moon in this in order to make a solar eclipse happen on the Earth? Over here somewhere? Yeah. So I might have not gotten the size of this right, but you know what? It would be maybe a good idea if I just kind of pick a size for the sun. And then I'm going to do what I did before. Let's see. Trying to think of a good choice here. All right. I'll just do this. There. I'm going to make it a little bit bigger. These sizes may not be exactly right, but this is representing the moon. Which side of the moon is dark? Left or right? The left, because the sun's over there. So what moon phase would we be seeing here? If we look out at it, yeah, we're just going to see this dark side. So this is going to happen on a new moon. And I'm going to do what I did with the warm-up. I'm going to draw 4 lines. There's one. And here's another one. And just one. Oh, no! Oh, no. I'm going to make the moon a little bigger. There. Oh, I'm making it a little bigger. Does anybody know why I'm making the moon bigger? Because I made it so small that we wouldn't actually have a total eclipse anywhere on the Earth if it was like that. And I'm missing one line. I'm missing this one. All right. So dark side of the moon is here. Can you see the place where you would have to be on the Earth for a total eclipse? Like if you were here, Would there be a total eclipse?
No.
No, because you would be able to see this part of the sun right here. You could look right over and see it. And if you were here, you couldn't. So what's the shape of the shadow where you can't see any of the sun?
Probably like an oval.
Well, on the Earth it would be an oval, but it's this triangular thing in here. This is what's called the umbra. So this triangle is total darkness, anything in there. So if you were right here on the Earth, you wouldn't be able to see the sun because the moon would be in the way. If you were over here, then you could see part of it. All right. So let me get to the kind of question you're going to have to answer now. First, when the moon is here, is this a solar eclipse or a lunar eclipse? Solar. Solar eclipse means we can't see the sun because we're in the shadow. Where would I put the moon for a lunar eclipse? Back here. So during a lunar eclipse, I'm not going to go through the kind of drawing that I was drawing before. During a lunar eclipse, the moon is back there, and it's in our shadow. So this would be a lunar eclipse. Let's do some moon phases now. So I'm just going to draw a couple more moons. If we looked out at this one from the Earth, what phase would we see? Quarter. Would we see a waxing or a waning quarter? Waxing, because we just see this side right here, and we'd see half of it light and half of it dark, and it would look like this, just like what I drew there. So here's the kind of question you're going to have to answer in just a minute. If the moon goes around the Earth like this, same way that the Earth rotates, how many weeks is it going to be from this moon until we can possibly have the next eclipse?
About a week.
So to here. And what kind of eclipse could that be? A lunar. So how about from this moon, how long is it going to be until the next possible eclipse?
1 week.
A week. What kind of eclipse could it be? Solar. How about this moon right here? How long until the eclipse, if that's the moon? 1.5 weeks, because if you divide the whole thing up into quarters, each one's a week. So this is a half a week, this is a full week, and what kind of eclipse is that going to be? Lunar. So that's the type of question that's being asked on this page. I'll do a couple of them with you and then give you some time to do the rest on your own. Get this going again. Okay. So this first question is about moon A. It's right there. You can label your diagram however you want, but the first question is the number of weeks until the next possibility of an eclipse. So think about it. Don't say it yet. Just think. In order to answer this question, you're going to have to figure out, you're going to have to know which of these moons can give you an eclipse and what kind of eclipse it could be. So I'm going to start from A. Somebody tell me when I get to the eclipse. Right here. Okay, so when it goes from A to H, we're going to have an eclipse. If the moon is here and the sun's over here and we're here, is it going to be the kind of eclipse where we're in the dark or the moon is in the dark? We're in the dark. And what kind of eclipse is that? Solar. So the answer for A is 1 week, and it's going to be a solar eclipse. And then for B, B is right here. So tell me when I get to the next position where there could be an eclipse. Okay, we missed it. Well, yeah, F right here. So is this the kind of eclipse where we're in the shadow or the moon is in the shadow? Sun's over here, the Earth's here, the moon's there. Are we in the moon's shadow or is the moon in our shadow? Moon's in our shadow. So what kind of eclipse is that? Lunar. And how many weeks is it from B to F? half a week. So if I do this, these are all full weeks. So G to F would be a full week, B to F would be a half a week. So the answer is a half and lunar. Yeah, 0.5 is fine. So try the rest. I'll give you a little time, and then we'll compare answers. It's really, all you have to do is know which one's which and be able to figure the time. You may come by and look. I don't know. I'll check one of them. D. 3.5. It's 3.5 until there, but there could be an eclipse here. 1.5. And it wouldn't be solar. And I realize the one thing I've left out of this packet is why we don't have 2 eclipses every month. I kind of make it look like every month we should have 2 eclipses. But there's a reason we don't, and we'll talk about it later. All right, Tracy, you can catch up on that later. Tell me when I'm going to go around like this. Tell me when. No, that's where it is now. So there wouldn't be a. There's going to be an eclipse here. Here, the sun and the moon. And so the shadow is going to be on the earth. What kind of eclipse is it? Oh, and how long does it take? It's a week. It's 4 weeks all the way around, so a week from here to here. So from there to there is, how much is a week? Full week or half week? Half. So the time. Yeah, that was why I picked that one.
I believe in you. You're gonna win the sea tournament.
I have. We only won.
So
You play the other people who you have. They're trying not to trash. Probably should make the team.
and round and around and around. There are 2 places on here where you have sun systems. All right, point out the 2 places.
I was a little able to soccer.
Earth blocks the sunlight, and there's a shadow on the
Yeah,
trees.
he's,
Here there's a shadow on the earth. It's called solar eclipse.
If you look at making which kid. That's why he started from here to here.
What?
If you play basketball and you're
So how many weeks is it all the way around?
low.
It's 4. So
I'm better.
each of these is a week. This is
I could beat him if I ever tried. I'm too fat and lazy. My name man. What's his name? Chase Morrison or dude, Chase is on it.
So, and you could like. Hold on for just a second. I'm gonna give some general help to people because the first few people I've been by, I think this would have helped them. So the first thing you need to be able to do from this is of all these different moon phases. Prince, will you be quiet? In fact, I'll use you as my guinea pig here. So Prince, how many different moon phases are there in this picture right here? Don't help him. So there are 8 different moon phases, and we've been working on how to figure out what their names are and what they look like, how to draw them, and that kind of thing. 2 of these, Prince, 2 of these moon phases can cause eclipses, and an eclipse happens when something blocks the light from something else. So basically, the diagram up here is maybe not as clear, but if you have the sun and you have the earth like this, and you have the moon over here, can either of these block the light from the other one?
No.
No. So how do I need to arrange these three things so that one of them can block the other one's light?
You could like take the sun and like put it right here.
Put down here. If I put the sun over here instead of there, would that put one of these in the other one's shadow?
Yeah.
So this one's it's going to shine light like that and shine light like that. Neither one of them's in the shadow. The shadow of this is back behind, and the shadow of this is back behind here. So how do I need to arrange them to get an eclipse? To have one of these two things be in the other one's shadow. Like right now, let's. I'm going to get my phone, my terrible illegal phone. No, it's useful in this case because I'm doing science. So I've got my mouse and my paper, and I want to put the paper in the mouse's shadow. So what do I need to do with my phone? I'm going to shine a light. I'm going to use this as a flashlight, and I want to have this thing cast a shadow on that. Where do I put my flashlight? Like this? Can you see the shadow of my mouse?
Yes.
So when I go over here, the shadow's over there. When I go over here, the shadow goes over there. So if I did it like this, then this would be in the shadow. And if I put this over here, I can put it in the shadow by moving my phone over here. And if I want it to be in the shadow, I can also put my phone over there. But if I do it like this, you know, the shadow of this thing is over here, the shadow of that thing's over there. So back to my question, if I have three objects, a source of light, like the sun, and then I've got two other planets, and I want to put one of these in the other one's shadow, how do I need to arrange them? This triangle is not working. What do I need to do? What shape do they need to make? Shape. They're making a triangle right now. If I change the positions of these so they're no longer in a triangle, I could get them. I could put this one in that one's shadow. I could put that one in this one's shadow. I'm about to pass. Do you want any more time to think, or do you want me to pick somebody else? Somebody else. What shape do I need? Just blurt it out. Anybody? No! 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 Declan?
Triangle?
No! Okay, so I must be explaining this poorly. So here's what I would do. I would take the moon and I would put it here. So now I don't have a triangle. I pretty much just have a line. So I need to line them up. So if I have my mouse here and my little pad there, and then I put my phone, let me move way back here. If I put it over here, so that it's not a great shadow, but you can still kind of see that there's a shadow there. So that this thing and this thing and this thing form a line, the light's gonna hit this and it can't get to there. But if I do it like this, you know, where my phone and this, they're in a triangle over here, that doesn't work because the shadow of this one's going to go that way and the shadow of that one's going to go that way. And in order to put something in something else's shadow, you have to put it behind. So these are the two ways you can get an eclipse. You can have the Earth here and the sun here, and you can have the moon there. Where else could I put the moon to get an eclipse? There's only one other place. This is one way to make a line. What's the other way? I could put it here. So those give me two different kinds of eclipses. When I put it right here, where's the shadow? On the moon or on the Earth? Shadow falls on the Earth. The Earth gets dark. But if I do it like this, the sunlight hits the Earth, and then the moon is in the Earth's shadow. So this is the kind where the Earth gets dark. This is the solar eclipse. And over here, this is the lunar eclipse. And if thinking through all this is just too tricky for you, you can remember it, you can just memorize it this way. What is this moon phase right here? Here's the dark side of the moon. There's the Earth. If we look out at it, do we see the light side or the dark side? I'll make it bigger. Maybe it's too small. Maybe that's why nobody's answering. Thank you, thank you. So if this is the Earth, and this is the moon, and this is the sun, and I darken this side, when we look out at that, we're seeing nothing but the dark side. So what's the name of that phase? Totally dark moon. What's it called? Naya? New moon. So new moon, you always have a solar eclipse. If you just want to kind of memorize it that way, you can do that. If reasoning through it's not working for you, new moons you can have a solar eclipse because a new moon blocks the sunlight and you get a shadow on the Earth. The moon over here, this is the one where you get lunar eclipses because this is the one where the Earth blocks the sunlight and then you get a shadow on the moon. So what's the phase of this? What do you see when you look out from the Earth at this moon? Here we see the dark side. What do we see when we look over here? Do we see this dark side? No, we see the light side. So what's this called? What's this moon phase? Anybody? Full moon. So on a full moon, you can have a lunar eclipse. On a new moon, you can have a solar eclipse. So on your diagram, if you want to make it really simple, this is the new moon. This is when you can have a lunar eclipse. Sorry, solar eclipse. And this is the full moon. This is when you can have a lunar eclipse. So these should be pretty simple. If you started a waxing crescent, started a waning crescent, C, you just go from here to here, and I've hit my first eclipse. And how many weeks is it from there to there? Half a week. So 1/2. And what kind of eclipse is this? Solar. And if I do moon D, I start from here. Tell me when I've hit my first eclipse. Right there. How many weeks is that? 1.5. And what kind of eclipse? It's a lunar eclipse. 1.5 lunar. So finish those up, and then we'll compare. I appreciate you trying this. That lets me know whether you get it or not, and then not waste my time explaining or not explaining if I do or don't need to. So you got it. Good. E. So it started E. I just labeled one of my paper, but you can see my paper. So this is where you have solar. And so that'd be a solar. So 1.5.
That's a bad demonstration.
That'd be a solar.
Dude, all I saw was this.
F is a trick one, so let's go to G. You tell me when I get to the next eclipse. Right there. From here to here. Maybe one way to think about it is from one moon to the next.
What Prince is about to get up and start dancing. Probably your hips on live.
This is where you have lunar, not solar. So. Moon causes solar. Right here, so the only good eclipse is these two. Each of these is half a week.
Pacers, I can't watch them play Fortnite, dude. You're wild, wild. Yeah.
What did you do for number, or letter F?
For your partner.
Oh, yeah. No. What? Never mind.
California. Yeah. Why love California?
Like that.
I'm out of Oh, you're inside again? Yeah. Yeah.
Sorry. So those of you who just totally get it, you're probably chomping at the bit to move on. Here are the answers really quickly. From E, the next eclipse is, so one way to do this is each moon phase is about a half a week. So this would be a half a week, a full week, 1.5 weeks until a possible solar eclipse. 1.5 solar. If I start at F, I don't need to go anywhere because that's a full moon, and on full moons there can be eclipses, lunar eclipses. And then if I start from G, the waxing quarter, I go from here to here, and there can be an eclipse here, and it's a lunar eclipse. And from G to F, it's a half a week plus another half, so 1 week. 1 week, lunar. And if you're having trouble identifying which of these moons gives you a solar eclipse and lunar eclipse, we can work on that later. All right, tides. Have you ever heard of spring tides or neap tides? You know what? Let's take a break. Let's take a break.